Thanks for having me here. I'm one of the founders for Cloudera. My name is Amr Awadallah. I actually got my PhD from Stanford with Dr. Mendel Rosenblum in virtual machines. I've been at Yahoo for Cloudera. I was at Yahoo for 8.5 years. And at Yahoo, that's where I got to experience this technology as a user of the technology. I was not in the team at Yahoo that built Hadoop. Doug Cutting, who also works at Cloudera, many of you might know, is the creator of Hadoop. He does work in Cloudera. Rather, I was one of the very first business intelligence teams in the world to use Hadoop. And from using it at my tenure in Yahoo, that's where I got to realize the power it provides, and that's when I left and created Cloudera. So the sequence for the presentation today is, I'm going to tell you my story of why I adopted Hadoop. I'm not going to tell you what Hadoop is. I assume many of you know what Hadoop is already. Actually, can I get a show of hands? So many of you know what MapReduce means and what HDFS means. I'd say about 80% of the room. So for the remaining 20%, I'll touch briefly on it, but I'm not going to go in a lot of detail about Hadoop itself. I will talk about a new technology that Cloudera released called Impala, which brings low latency interactive SQL capabilities to the Hadoop ecosystem. So I will talk briefly about that as well during this presentation. So with that said, first, what are we building towards? This is it, right? It's like, and I know for an HPC audience this might be a bit disappointing, but it's like a data warehouse. It's a data warehouse that is capable of storing way more data than ever before, different types of data, so not just structured data, and it's much more flexible in how it allows us to do analysis over data. So it's not just SQL queries, it can go beyond just the SQL capabilities. So that's the high level of what we're building towards. Now the additional benefits obviously is it's open source, right? It's 100% open source. And it leverages commodity hardware, so the economics of deploying a system like this is 10 times to 100 times more cost effective than existing solutions. That's kind of a very high level summary of what essentially we enable. So very briefly for the people in the audience that never, 20% that didn't raise their hands, Hadoop, I like to say Hadoop is a data operating system. That's what it is. So it's just like Linux, it's just like Windows, it's just like any other operating system. At the heart of any operating system, what they do is two core functions. Well, sorry about that. Yeah, so the core of any operating system, what they do is distract you like this. What they do is two things, right? They store files, and they run applications on top of files. That's what any operating system does. If you go back to DOS, 20 years ago, that's what DOS did, right? Allowed you to have files and run access files. The only difference with Hadoop is that obviously, as you know, it does that on a bunch of nodes, right? So it allows you to take many, many nodes together and join them into this massive resource that can be used to store lots of files and run scalable applications, data applications on top of this. That's really what Hadoop does. I sometimes say it's the opposite of a virtual machine. Sometimes I describe it that way. So the virtual machine companies like VMware, what they do is that now you can take a physical server and then chop up that physical server into multiple smaller virtual servers. That's what virtual machines do. Hadoop is kind of the opposite of that, right? Hadoop is about taking many, many physical servers and then joining them together to look like one virtual master server. Like a mainframe made out of small blocks. The core functions are HDFS and MapReduce. I'm not going to dive into those. I will dive and stress over and over again, like why? Why is Hadoop being adopted by the industry at large right now? And it boils down to these three things, which I'll touch on further during this presentation: flexibility, scalability, and economics. And in fact, I'm going to ask you to try and remember these three keywords. That's the whole kind of goal of this presentation. Get to remember these three keywords. So this is the story. This is my story, and this is the story of why Hadoop now is being adopted in many, many industries. And I refer to this as the story of T. T stands for transformations. T stands for transformations. So to understand the story, we need to go back to about 40 years ago when we started building applications on top of OLTP, online transaction processing systems. So we build applications that serve end users, and then we have all of our data inside our OLTP system. But the next thing is we want to ask questions of the data, right? So what we did is we linked our business apps directly into our database, and that was a big mistake. It was a big mistake because this database was not built to do queries and business intelligence. This database was built to do transactions, right? So we ended up not only getting bad performance for our queries, but we also ended up getting bad performance for our transactions. So that was a whammy. So very quickly, within a few years, the industry shifted away from doing BI this way to doing it this way. We added the data warehouse in the middle, right? And the data warehousing industry was born. And in this picture, what we do is we have a database specialized just to run queries very, very effectively. We have all our transaction systems, and in the middle we have this process called ETL, it's a standard term in the industry, which stands for extract the data, transform it, and then load it from the transaction systems and the online data stores into our warehouse systems. And this worked for us. It worked for us for about 20 years now, but now it's starting to break. Because as we added more and more data, this transformation ETL process wouldn't fit anymore within the software we had. The software, the industry software for doing ETL, it wouldn't scale. So the industry quickly moved away from what's called ETL to what's called ELT. So in ELT they said, let's see if this works. In ELT they said, since we have these big databases here, and these databases are scalable, how about if I load my data right away? So just create a column called blob. And in the column called blob, just dump all of my data, structured or unstructured, doesn't matter. And then I'll run a transformation inside of my data warehouse that converts my data from unstructured format to structured format inside my data warehouse. Right? And that was a repetition of the mistake we did back here. We're taking a system that was really built to do queries, and we're making this system do transformations, which ends us harming us in two ways. Number one, it actually doesn't do the transformations very well. It doesn't do them cost effectively, and it doesn't do them in reasonable time. And second, by doing the transformations here, we end up slowing the thing it was built to do, which is the queries. Right? So industry after industry, you will see people complaining about how slow their database is because of this problem. All of this is further kind of stressed to its limits by the wave of big data, right? And you guys might have heard these words, or volume, meaning data being very big, velocity, meaning data changing all the time, it doesn't have a fixed format, and then variety, many different types. This really stressed our data warehouses. They couldn't keep up. And this transform function, we couldn't finish doing our transformations within the time windows enforced on us. So in fact, myself at Yahoo, my ETL window was 9 hours. I had from midnight, when the day ends, to 9 a.m. the next morning before the business analysts come in to finish doing everything. So 9 hours. I was at 8 hours. I had one more hour and I was going to get fired. Right? So I needed to find something new. I need to find a new scalable way that lets me just solve this ETL problem. Again and again and again, we will see customers adopting Hadoop for this problem, and we see the transform function dropping from 9 hours to minutes with a fraction of the cost. So, because that's what Hadoop was built, is to do this function very, very well. The second problem, obviously, if I have my system very busy doing the transformations, then my queries become slow, the SLA performance for the queries is not very good, and the business users get really, really upset, right? So they get upset because I cannot give them the data by 9 a.m., and then they get upset because when they run the reports, they don't get the result back right away. And then a problem which was very, very dear to my heart, because these systems were very, for the lack of a proper term, I'm just going to say expensive on a per terabyte basis, we couldn't keep our data indefinitely. So we had to enforce retention windows. right? We would say we would only retain our data in the data warehouse for about 6 months to a year. And then once it gets older than that, we archive our data. We send it to archive. And as all of you know, once data goes to archive, forget about it, you don't see it again. Archive is the graveyard where data goes to die. We typically say it takes an act of God or government to bring back data from archive, meaning a natural disaster and you have to recover your data, or a subpoena to investigate your records. And data was being sent to the archive even though it still had lots of value in it. And in aggregate, if you have 7 or 10 years of data, lots of value in there. But we just couldn't keep it. We couldn't justify keeping it. And I'll talk about that later on. So this is really what Hadoop and what Cloudera is all about. It's about enabling that, right? It's about enabling organizations to augment their existing data warehouse infrastructure with a capability that allows them to do transform much more effectively and economically to meet their operational SLAs, allows them to do query over the historical data as well, and frees up the data warehouse to focus on high-performance queries for the most recent high value. And that's really the industry after industry after industry after industry, whether it be finance, retail, telecom, media, government. This is what Hadoop is being deployed for first, right? Data science and advanced analytics comes next. But the bread and butter problem that Hadoop is solving over and over again is this operational efficiency story, which we refer to as data warehouse optimization. It's about, I'm running out of capabilities in my data warehouse, help me. And then once they adopt Hadoop and once they have Hadoop inside their infrastructure, then they start to realize, oh, Hadoop can actually run algorithms. Hadoop is not just SQL. Oh, Hadoop can store data of any type, videos and images, not just columns and rows. And that's when the data science gets in. But the WAC, we refer to, like our chief data scientist, his name is Josh Wills. I'm sure many of you are familiar with the movie Karate Kid. And from the Karate Kid movie, this is the wax on, wax off. If you don't get the wax on, wax off done right, it doesn't matter. You're not going to be able to do data science. You need to get this done first. Otherwise, you'll never be able to do the advanced stuff. So now I'm going to go over the 3 key differentiating benefits for Hadoop and this new way of doing things. And this is the key one by far. This one here is the key one by far. This is really why Hadoop is unique, and this is really why Hadoop is different than traditional database systems. So I'm going to spend some time on this slide because it is a very, very key slide. Traditional databases and legacy systems, they follow what we call a descriptive data modeling approach. They prescribe on you what your data will look like. They prescribe on you the schema ahead of time. We also refer to it as Schema-on-Write, meaning at write time, before you can load any data or put any data in my system, you have to create a schema first. And if any new data comes that doesn't fit that schema, you cannot put it inside the system. It can't go in. If I later on want to change my schema and there's new data I have to go through an awareness process of creating that column, which in many data systems can take actually days to add a new column inside the database. There's actually also logistics even ahead of adding the column that make it take longer. At Yahoo, I used to say, when I'm lucky, if I want to add a core column or a core attribute in one of my data models, when I'm lucky, it will take 2 weeks. Most of the time, it will take 6 months. 6 months until I get approvals from every single consumer of that data model that they're okay with adding that column. 6 months. That means by the time I actually edit the thing, the business question behind it is gone. Right? We can't be agile with an infrastructure like that. This approach is really good for what we call the known unknowns. The known unknowns. Meaning the questions that you know ahead of time. You don't know the answer for the question, but you know the question ahead of time, so you can design a schema and a model that can very quickly answer that question. This works great, right? Because you're paying the cost of parsing and cleaning the data at right time, and hence when you do reads, you can do reads much quicker. However, it limits your agility and flexibility. And this is really the main difference about Hadoop compared to databases. Is Hadoop says, we follow a schema-on-read model, also referred to as descriptive data modeling. I'm just going to describe my schema. I'm not going to prescribe it on you. At right time, you can give me anything. At right time, give me any data you would like to give me. I don't care. An XML file, a log file, a sensor data, images, videos, I don't care. At read time, when I'm reading the data, that's when I'm going to add a description to extract the schema that you care about. In fact, new data can start flowing in at any time, and you can come 6 months later and amend your description, and you will right away will be able to see this new data. It will be accessible to your queries. You don't need to reload, you don't need to redo your ETL. In a sense, it's like doing the ETL on the fly. We are doing transformations on the fly as we are consuming the data, as opposed to as we are loading the data. Very, very fundamental difference. This approach, obviously, is very good for the unknown unknowns. It's really good for the questions that you don't even know ahead of time. So not only do you not know the answer, you don't even know the question you want to ask. So it's very good for exploration. And then once you find a question that is a high-value question, that is repeatable, then it makes perfect sense now to move the data underlying that question to a system like this. So you don't have to pay the parsing cost every time you ask the question. It's very, I hope this makes it very clear, but this is the core difference. Like whenever, sometimes you hear this question, why do I need Hadoop when I already have a database? This is why. This is why, more than anything else. It's the agility and flexibility of being able to ask any question of your data without having known what the question would have been ahead of time. The number 2 benefit is scalability. I mean, this Hadoop is very famous for this, and sometimes people think that this is the first benefit. Hadoop scales, is proven to scale to hundreds of petabytes and thousands of nodes. No other commercially available technology today is proven to scale to these levels. There's technologies inside of Google, inside of Microsoft, inside of Amazon that do scale, but in terms of software that you can deploy, this is the only thing out there that is proven to scale to these levels when it comes to data storage and processing. Obviously, the flagship example is Facebook has a Hadoop cluster with more than 4,000 nodes and hundreds of petabytes inside the cluster. Single namespace. Single namespace. That's not like I have a petabyte here, there, and add them up. This is a single namespace. The other key point with scalability is it's not just scalability of machines and scalability of throughput and scalability of processing. It's also scalability of humans, in the sense that the same queries and the same jobs and algorithms that I write to work on 3 nodes will work on thousands of nodes. I don't need to go and redo my queries and repartition the way I'm laying out the data. Just transparently, as I add more nodes, that gets done for me. Last but not least is the economics angle, which goes back to the data archiving thing I mentioned earlier. Most organizations today, they're only keeping the tip of the iceberg. They're only keeping the tip of the iceberg accessible to the questions they want to ask. And they're archiving everything else. And everything else has more value than the tip. It doesn't have more value density. It has a lower value density. So we have this term we define called return on byte. Return on byte is similar to return on investment. Is how much value am I getting out of the byte as a function of the cost of storing that byte? And obviously, as the value drops below the cost, I can't justify keeping it in my high-cost systems anymore. And that's when I archive and I lose it. Even though the density for that byte is low, the aggregate value is huge. Hadoop, as many of you know, because of the open source nature, because of the commodity model nature, the cost per terabyte is a few hundred dollars per terabyte. That includes paying Cloudera money for support as well. If you look at traditional data warehouses, you're talking at anywhere between 10K to 100K per terabyte. So you're talking about an order to 2 orders of magnitude difference in costs. One other analogy we might use here is from the airline industry. Not all of your data deserve to fly in first class. Right? Some data deserve to fly in first class, and you want to put it in the high performance, high cost system because these bytes need to get there ahead of everybody else. But most of your data would do fine with economy class. Right? So that's another way to explain this. And it's much better to put it in economy class than archive it and never see it again. So this is what the architecture looks like in most organizations. I kind of covered it already at have in the Cloudera offering. So you have Hadoop here in the middle for the storage. We have a system called Flume. Flume is built for doing collection of data, especially unstructured data. So you can hook up Flume to log files, to crawling web data, etc., etc. And Flume is very scalable in nature. So same thing, it has many agents, and you can scale it out and collect that data and put it inside of your Hadoop cluster. Scoop, very similar to Flume, but Scoop focuses on structured data. So Scoop is short for SQL to Hadoop. You can very easily point Scoop to your database and say, grab that table, it will get that table and materialize that table inside Hadoop, and vice versa. You can take a file inside Hadoop and use Scoop to load it inside your database. Like here, for example, once you want to publish, the outputs into your other system. There is one of the popular ETL development environments is called Informatica. That's your design ETL process. You're still able to use that design process. You just push the execution to run inside of the cluster. Same thing, data mining tools like SAS, R as well. Even if you want to do Java development, all of this now you have access to go with some of them, the high-level ones, you have choice to go to Hadoop or to your data warehouse. And they will do that transparently for you. So MicroStrategy, for example, MicroStrategy has what's called multi-source data modeling. Multi-source data modeling, meaning you can have a data model that is written to map to more than one source. And as you're doing your reports, as you're doing your drill down, as you're doing your query, business intelligence, it will intelligently detect when you're zooming into too much detail, that detail doesn't exist here, I have to go here. Or if you're zooming into much history, that history does not exist here, I have to go there. Okay? That's kind of some of the layers inside the Hadoop ecosystem. Now, one of the key technologies I want to focus on today, which I'm going to spend a couple of slides on, is Impala. Right? So first I want to ask how many of you heard about Impala? You can raise your hand. Very little, almost nobody. So Impala is a new technology that we released that brings low latency analytics to the world. So before Impala, you have this picture on the left. And sorry, now I'm going to go a bit deep in some of the core projects inside Hadoop. You have the HDFS and H-based technologies for storage. You have MapReduce and HiveMP for what's called batch processing, the transformations workloads. And then you have user interfaces on top that allow you to express your queries in high-level languages. You also have a metastore that contains a mapping of a file name to essentially what schema does that file have, and how can I parse that file to extract that schema. So every file has a parser. And put this inside it's called the Hive metastore, though you might also learn about HCatalog. They're both the same thing. So this was the world before Impala, and the only capability we had was really about batch processing. And Impala comes in and fixes that, right? So Impala runs side by side with MapReduce. It does not depend on MapReduce. It does not use MapReduce. Impala runs directly on top of HDFS and HBase. Impala, unlike MapReduce, is written in C++, very highly optimized C++. MapReduce, as many of you know, is written in Java, the framework. And Impala leverages the same metastore. So it's a drop-in replacement. Whatever tables you could access with Hive, you can access with Impala. The design goals for Impala are fundamentally different from the design goals for HiveMP and MapReduce. HiveMP and MapReduce, the design goals was high throughputs. How can I run transformations at the highest throughput possible? The design goal for Impala is low latency. How can I get you back the first few bytes of an answer as quick as possible? So it does have a different design goal. Again, for those of you familiar with the MapReduce framework, the MapReduce framework is optimized for high throughputs, but also for failure tolerance as well. Because if you're running a job that's going to be taking 9 hours, and a couple of servers fail during that job being running, you don't want to have to restart the whole 9 hours from scratch, right? So MapReduce has a lot of that kind of extra work it does to provide everything for you, but that extra work can slow things down. In a nutshell, if you have a SQL query that's written in Hive, you can take that SQL query and run it in Impala. For the small queries, it's going to run 10 times to 100 times faster. Before Impala, if you were running a SQL query in Hadoop to fetch just 1 byte, you just want to get 1 byte back. That 1 byte would take 2 seconds or 3 seconds to get back. the answer to your question was just 1 byte. It will still take a long time because MapReduce has a very heavy planning process to how to kick off a job. In Impala, you get back in milliseconds. You get back the answers in milliseconds. The first byte will come back in milliseconds. That's the key differentiating aspect for Impala. Impala, just like the rest of the Hadoop ecosystem, it's open source. So just like everything else, Apache license and so on. And so you guys are working to build and try it. We maintained, so again, the 3 keywords I mentioned earlier, scalability, flexibility, economics. We maintained all of these core tenets and attributes in design in Impala. So Impala is scalable. You scale it simply by adding more nodes into your cluster. You don't need to rewrite your queries as you start consuming more data. Impala is flexible. It maintains the benefit of I don't have to define my schema ahead of time, so the descriptive modeling as opposed to prescriptive, so you can evolve your data very quickly. And obviously, it inherits economic benefits from the underlying platform. The cost per terabyte is a few $100 instead of a few $1,000 to 100. So what about my RDBMS? This is the question that some of our customers ask. Does this mean I go away and throw away my relation system? No, you don't want to throw away the relation system. Relation systems are good at what they're good at. That's the whole point. They're really good at doing transactions. You want to keep using them for transactions. And they're really good at doing OLAP queries. You want to keep using them for doing OLAP queries. You want to keep using them for that. However, they're not good for doing exploration. They're not good for investigating the unknown unknowns, as I mentioned earlier. Right? Because they're very rigid when it comes to changing their schemas. And scalability-wise, Impala is proven to scale much bigger than any of these existing technologies right now. In terms of, like, if you really want to go and run a query over your last 11 years of data, you just can't do that. Or you can do it, but you have to pay a lot of money to do it. So it really boils down to these kind of 3 things here. Is RDBMS does not allow you to just dump in raw data of any type. It doesn't allow you to evolve your schema flexibly, and of course the storage costs are much, much higher. This is a more detailed list. It's more as a reference slide for you for after the talk. You're going to get access to slides, but covers some of the key functionality in Impala. Impala's goal is to go after the SQL space, so it's not kind of a high-performance Turing complete language, but obviously you can do a lot of things with SQL. And Impala covers most of the common kind of SQL syntax is already covered in Impala as well. And it gives you access over many different file types, so it's not just these 7 types. You can text files, sequence files, RC files. Alpha and Trevny are new descriptive format files. Trevny is a columnar file. You can use your own compression codecs to get the benefit of compression, etc., etc. We want to add soon, hopefully this year, we'll add support for user-defined functions, which allows you to add some logic into your queries, right? So you can reach out to the MapReduce capabilities and add some logic beyond just the SQL language. And also windowing functions is one of the highly requested features. For those familiar with the SQL syntax, windowing functions allow you to essentially time series analytics, right? You can, inside the query, you can refer to previous rows or forward rows. The functions are always interact. So the goal of this slide is to answer the question that is sometimes get, which is, so how does Cloudera make money? Yeah, it's open source, and all this stuff is free. How do you guys make money? So this is kind of our answer to that question. This is our business model. Our business model is 3 things. Support on the open source software, professional services and consulting, and training. Right? And training covers all the way from developer training, administrative training, up to data science training as well. So we do have data science training courses that we give every time. So why would somebody want to buy support at a very high level? If I were to tell you right now, look under your chairs, there is a key for a new car outside for you. There isn't. If I were to tell you that there was a key, do you expect not to pay any money for that car going forward? And the answer is no. You will have to pay insurance, you'll have to pay maintenance, you'll have to pay gas, at least, right? So same thing. Like we tell our customers, you can go ahead, install the software, deploy it, use it as much as you would like. Once it's production, once it's mission critical, that's when you need to have a contract with somebody like Cloudera. So that if there is a problem, you want to have a guaranteed SLA for how quickly that problem will be solved. Because in open source, if you go to the open source kind of forums, it's a best effort response. It's not a guaranteed response. And that's really what they're paying for. They're paying for the guaranteed response for when they have a problem. We do also include as part of our software, when you are a paid customer, besides the open source platform, we do include proprietary software for management. So we have a console for managing all layers of the Hadoop ecosystem: Flume, Scoop, HBase, Impala, etc., Zookeeper. All of that is from a single unified management interface that provides monitoring, alerting, and warns you about, it has wizards that warn you about configuration problems or about issues that might be coming up inside the process. So simplify the management of Hadoop. This is my own slide. I'm going to skip over this one. Actually, anybody from finance here? Anybody from a big bank or a big credit card company? Let's skip this slide. Just go to this one because there's many use cases here. I just want to cover a couple of use cases from the slide, and then I'll conclude, and then you can ask any question you like. Since we're doing well on time. So we now have deployments of Hadoop and customers across every industry you could think of. Like at the beginning, when we were starting the company, myself and my co-founder, Jeff Hammerbacker, from Facebook, and Mike Olson from Oracle, at the beginning, we were thinking that this technology would only be for web companies, but it became very clear very quickly, this is way more than web. This is way more than web, right? So we have customers now in finance, and retail, and telecommunications, and media, and the government, because this common problem of data growing very quickly, data changing all the time, I want to have a more flexible schema, it's everywhere, right? Now the manifestation of it is different in different industries. So I'm going to pick a couple from here. I'm going to pick the first one there, first satellite imagery. Any of you, actually they're out of Stanford, this startup, any of you heard of Skybox imaging? Skybox imaging? So Skybox, what they do, Skybox imaging, is they build very cheap commodity satellites. They're very cheap, they're $10 million each. So it's very cheap on satellite language speaking. But that $10 million includes, $10 million includes the satellite and launching of the satellite. So they're in space on these launches. So they build these satellites, and their specialization was coming up with how to read those satellites using one power and lay down the bolts of the satellite, but also imaging technology. They have very, very unique imaging technology. They launch these satellites into space. They have a number of them rotating the Earth. Eventually, they want to be able to cover any point on the Earth at least once during the day. They're not there yet. They stream all of these images in real time to a massive ground Hadoop cluster that analyzes the images and extracts information from inside the images. And their business is to sell that information. So they're not selling you the images. You can buy the images, but they're selling you information from inside the images. So here are some examples for this. One example is in the obviously financial analysts. So they are analyzing whether Walmart is going to do well or Home Depot is going to do well. One of the key metrics they want to look at is how many cars are parked in front of them. Right, so a very good proxy metric for whether Walmart is going to do well or not. So now they can literally buy a feed day by day. How many cars are parked in front of every Walmart location in the world? Another example of how this information could be very useful is insurance companies. Insurance companies, before they insure your home, they have to send a contractor to look at the roof of your home, which costs about $500 or $1,000 to send a person out. Now they just buy this information. You can buy an image of the roof of your home yesterday, and an algorithm can analyze the quality of the roof, basically. Same thing, oil and gas companies, pipelines have to be inspected all the time. Now they can do that. So it just shows you how Hadoop, obviously this is not just Hadoop, this is all the extra technology they built for the satellites and the image processing, but it shows now how new applications like this can really be born now because of this capability. Another interesting use case as well is speak more about sensor networks for agriculture. Agriculture, one of our large customers, they are, I think I can say the name, but I'm not going to say the name. I'm not sure if I can say them or not, so I'm not going to say it. But we can guess who they are. They specialize in making seeds, new types of genetically engineered seeds that can grown in different environments across the world. So they have very large fields, lab, where they test these new seed combinations. So they do A/B testing of the seeds. The seeds are in NAS batches in different environments. They have sensors that measure the temperature, the humidity, the soil composition, and they measure laser sensors that measure the rate of the growth of the crops. And all of that is collected back into the Hadoop systems they have to correlate that against the new type of seeds that they have engineered. So it's another example. And you guys coming from the high performance computing industry have many more. But you can see the trend here. It's not just about solving existing problem of my data is growing, my data is changing. It's also about enabling new problems as well. It's like both of these flow from the sweet spot. So now I'm going to conclude, and you guys are welcome to ask questions. Just want to remind you again of the three key things that are really triggering this whole, I would say, triggering the whole big data movement, not just Hadoop itself. Flexibility. Flexibility. We need the ability to store any data, not just structured data. We are beyond, because of sensor networks, because of mobile, and because of our sophistication and how we collect information, we are beyond structured data. Structured data is just the explicit transactions. There's so many implicit things that happen around that we need to collect and store. So we need a system that can handle all types of data. Run any analysis. Still under the point of facility. Run any analysis. SQL is great, but as many of you know, SQL is not Turing complete. You cannot do any algorithm you would like to do in SQL. You just simply can't. We want to go beyond SQL, and this is what the system allows you to do. You can do SQL, but you can go beyond SQL. Scalability. Proven to go to thousands of nodes and terabytes of data. There's no need to rewrite the work as you grow the system, and hence you can keep pace with the rate of growth of your data. And then last, but let me not use economics. You're no longer now forced to archive your data and kill your data when it's still young. You can keep your data around for much longer periods of time. That's it. So with that, I'm going to conclude and see if you guys have any questions you would like to ask me about Hadoop, Cloudera. Thanks for paying attention.